Alright, some end products. Had a few groans, had a few shrieks of excitement. So let's have a look. So I'm not going to go through the proof because I've already done that in extension and you're all present for that. You all will remember how to derive all this for me if I asked you to. Kidding. Alright, so if alpha and beta are the roots of the quadratic equation, sum of roots. Alright, the sigma sum roots one at a time is equal to alpha plus beta.
I never understood
And
this.
remember these letters and... Yeah.
Negative b over a.
Excellent.
I never... Like, I think I had this stuff remembered, like all the formulas, but I didn't know how to put it.
Actually answer the question.
It's called, it's basically the same thing as this stuff. Except you're grouping them up so you can get negative b over a.
Yeah, but I never got the whole one at a time, two at a time.
That's what you need to work out. Walk out of here knowing. Yeah.
Like, 'cause I remember...
Yeah, basically, apply it to this stuff. So alpha, beta, gamma is x. That's basically...
Like, I could literally just write... I remember I was able to just write them everywhere.
I remember that.
But I couldn't...
them on like...
I wrote them on everything. I put it on my folder.
Yeah.
I put that really big polynomial on my folder.
Awesome. Okay. Now, what's the chapter we're working on?
I can't remember.
What's it called?
10
What
point-
everything we've been working on?
10.5.
Binomials, quadratics.
Quadratics. Alright, so that means it only goes up to alpha beta. No further.
That's so boring.
I know.
Oh
Wait, you wait till extension 2.
god. One thing.
You wait. Topic of polynomials and extension 2. Oh, that's a lot of fun. Alright. Now, who remembers what the letters are here?
C over a.
Excellent. What comes next, Robin McCall?
Negative
What comes next?
a over a. Negative f over a.
Oh, yeah.
Excellent. Alright. So we've done some extension revision as well.
Alpha, beta, gamma.
Okay, example. So if alpha, okay, remember alphas has the curly tail. Okay, the other way to do it, you can do it like a fish.
That looks like...
Okay, make them look like alphas, not A's. Okay, so squish the tail out a bit. And beta, don't make a capital B, make the stem longer. Right. I'll be a bit pedantic, but anyway. So if alpha and beta are the roots,
See, you can run things out. I can't.
yeah, I probably shouldn't get in that habit, eh? My mum should just cross me up when I go. Alright, 3x squared. Take away 8x, take away 1, equals 0. We need to find. Part I. Right, so we need to find alpha plus beta.
I wonder. 8. It's 8. No, it's 8 over 3.
Alright, so remember our quadratic formula type. So it's ax squared plus bx plus c. That's where your a, b's and c's come from. So alpha plus beta from the formula is negative b over a.
Oh, right. Oh,
Does it make sense now?
yeah.
Did you get it wrong already, did you?
Yeah. But I swear there was something more complicated.
Yeah, when you have the long one.
It's called extension maths.
Well, when it was the...
And you had to group it all together.
Yeah.
That's coming.
That's
yeah.
probably when
That's
I was
coming.
like,
Negative 8 over 3.
I think this is where we're like, oh, this is easy, this isn't hard. And then the next lesson is like, no, we'll do it with this thing.
So if I find the roots of this quadratic, there must be 2 real roots for this to happen. Okay, so if I factorise and solve, and the two extension 2 students just give me a royal smile there. You have to find the roots, okay? And if I find the root and then I add them together, the value will be 8 over 3.
Someone discovered that.
Alright, so alpha, beta. Okay, so if I have had those two roots and I multiply them together, so instead of going through factorising or quadratic formula or even completing the square will work and find the two roots, two x values that make that quadratic true, I just have to do this.
The sum of alpha beta. The sum of 2 at a time. And because we're in the quadratic.
So if I multiply those two roots together, the value will be negative 1 over 3. Okay, so that notation, sigma sum alpha means sum one at a time, and sigma sum alpha beta. So you don't really need it because there's only going to be two roots for this section of the course. Okay, it's only for the extension students that can have more than two roots. Okay, just makes it easier for the shorthand. Alright, triple I. 1 on alpha plus 1 on beta.
This sort of stuff.
Yes, I think.
That sort of stuff.
Yes.
Yes. Okay, so basically you need to manipulate that and use your sum of the roots one at a time and two at a time to be able to get the solution. Okay, so if I take the reciprocals of both those roots and add them together, what's the value going to be? How am I going to work this out?
3 over 8. I was looking for that.
Is it,
No, that happened once. Can I tell you a funny story about
is it
polynomials?
A over minus B?
Say it again, sorry?
Is that
I said 1.
minus A over B?
No?
So,
I don't remember how
to tell you about that time, I was doing polynomials in the library and through when I actually did stuff in my studies. And I couldn't do it, and Brendan's like, the answer's 1. I went, no, it's not. Turn to the back of the book. And the answer was 1.
I think the funniest statement there was that I actually did work in the library for once.
He had like, no, I said it on purpose. I definitely said that because I did at once.
Right.
It just didn't work.
So, I need to manipulate this. Alright, so put them over a common denominator. Oh, yes, we're remembering. And cross multiply your numerators. Using your algebra skills. Okay, now that I've manipulated, I can now write down the results of those two expressions. Sure can. 8 over 3, because that's the sum of the roots one at a time, all over sum, the product of the roots, or sum two at a time. Negative 1 over 3. What happens when I divide by a fraction?
By the reciprocal.
Alright, equals 8 over 3. When you're dividing by a fraction, that's your main fraction bar, then we're going to multiply by its reciprocal. So we flip that fraction over and we put a multiplication sign in between them. Okay, and then we've got simplifying our fraction. Of course, 3 cancels, so we get negative 8 over 1, which is negative 8.
Didn't say that.
I think it's 8 over 3. Alright, IB. Poison ivy. A squared plus B squared. So if I square both the roots, then I add them together, what's the value going to be? Now, if all else fails, and you don't remember any of this, okay, you can still have all these answers if you worked out the long way. Okay, so you actually find the roots using your factorising skills, quadratic formula, or completing the square method if you want to be adventurous or have a bit of fun with that. Okay, you find the 2 root and then you perform these expressions. So you flip both the roots over for your answers, add them together, you'll get the same answer. Okay, if you square both the roots, then add them together, you will get the same answer. Okay, so we might even do that at the end. Alright, so I need to now manipulate this expression.
A plus B. A take away B.
Alright, so almost got this, don't I? Almost got the A plus B. I'm going to square the whole thing because this is almost the result of expanding a perfect square. Okay, and remembering if I expand this, it'd be A squared plus 2AB plus B squared. So I've got the A squared and the B squared, but I don't have the 2AB. So I need to remove it. Alpha beta. Alright, 64 over 9
Whoa. Alright.
plus
Yeah.
2 over 3.
Right.
70 over 9. 3, nope, that's it. Okay, so if we're to find the roots, square them, add them together, that's what I'll get.
I've lost my glasses.
Whoa.
Alright, B. Alright, so I want alpha take away 3 times the product of, times, in brackets, beta take away 3. So what happens when I subtract 3 from both of my roots? I multiply them together. What's the value of my root? What am I going to do? Using the foil, expand it. Right, expand and tidy it up. Now remember, in the bracket, I need alpha plus beta. So I'm taking the 3 out. Factor the 2 middle terms, so I'll get the alpha plus beta part of it. And I've got a constant number I'm going to add to it as well.
I get this.
Alright, so alpha beta, we should use negative third. Take away 3 lots of 8 over 3 plus 9. Can't do that.
Can't.
Well, I saw that in multiplication, but it's not. I can do this. So negative third, take away 8 plus 9, then negative third plus 1. 2/3.
Okay, there must have been something like that we did that.
This is basically it.
Really? What? I don't understand. What do I do? I understand that's the problem because I remember this being really
You
hard.
had extra roots to work with Kyle in extension. You didn't just have 2.
It's the same.
You had 4 at one point. We had to work through a question with 4 of them. Had a quartic with 4 roots.
Remember that 10-step equation? That covered like 2 boards?
Yep, I'm pretty sure that was the quartic.
Remember that time we came in early? We came in and we used to leave, wasn't we?
A over B plus B over alpha over beta plus beta over alpha. What do I do? Cross multiply, good. Okay, so put it over common denominator, alpha beta. So I've got alpha squared plus beta squared when we cross multiply. What do I do from here?
Substitute.
One person's worked it out.
Substitute.
Yeah, I've already worked out alpha squared plus beta squared, haven't I? Yeah.
Oh yeah.
So I don't have to go through all that manipulation again. I can just write the result down.
9
So 70 over 9 all over negative 1 over 3. So 70 over 9 times negative 3 over 1. So it's going to be negative 70 on 3. 3 does not go into 70. Alright, so I'm going to stop it there. I'm going to finish off those examples next week. Next lesson, sorry.
Is that a whole lesson?
Yeah, the bell doesn't go.
Well, the bell's going in about 13 minutes.
Oh.
Okay, so I'm giving you a bit of time to get some work done. And we'll finish all those off next lesson. Okay, and the quadratic identity is 10.4. Okay?
Can I grab my book off you?